Hi, this is Nicole Granucci, and I'm going to do a video of the Wheeler approach to analyzing a series of data in a series type of timeline chart. So I have to admit that I don't know anything about the stock market or the Dow, but what I did is took some numbers and I'm going to analyze them. So the approach that I took here was I went online and searched stock market changes, and I got this chart. And just because I was curious, I put September 2015 up to 2016, very similar to some of the examples in the book. So I took this, and what I did is, because this is kind of a noisy signal right here, I kind of just took these crosshairs right here and used it as a rough estimate of the plot for each month. So for example, at September I would put this here, and then I measured it. And of course these are all estimates because it's not super exact. So that's what I did to get all these values here. You can see as I scroll down like that, and Excel is wonderful because you can calculate averages pretty easily and do that. And then I did the moving range. Not average, this is the moving range. There we go. And just like the book example I did, I found the difference between the two previous values and found them right there. So I went ahead and did that. And then using the Wheeler equations, I found the upper limit for our moving range. And then let me just move this out of the way. Here we go. I found the upper range there. You can see my equation. And then I found the lower and the upper and the lower limits right there. So then I went ahead and plotted these. So I used Excel to do that. So I have the dates down here on the bottom, and then I have the actual values here. So if you notice too, something I noticed at least is the scaling. I mean, if you scale this, you could see there's these dramatic changes right here. I mean, right here, when I was first looking at this, I was like, wow, that's pretty crazy. You have this super low spot here, and looks like we're doing pretty good right here. And then I put it down to 0 just to see a quick glimpse at this, and you can see it actually kind of flattens out quite evenly. And then what I did is I put this red line to represent the average, so that's my central line. And then this is my upper limit right here, and this is my lower limit. Again, these are approximations because I don't have super accurate ways to do this, but looking at this approach, this blue line here represents the actual value. It's in between our upper and lower limit, so I would say this is just noise. I don't see any signal coming out of here. What would represent a signal is anything that goes beyond these dotted lines. So as I see here, I don't see any of the dotted lines, any of the values going outside the dotted line. So I'd say this is a pretty consistent system, predictable at this point. And for the last year, I was actually pretty surprised by this, to be honest, especially after looking at this. I thought this was going to be a little more crazy, but it isn't. So even if I do play with some of these scalings, I can format this axis here. So why don't we, just for fun, because it's fun to do this, right? 1400. No idea if this is going to be accepted, but you never know. You just try. Okay, here we go. So if you did something like this, and I put this back down to where I have it as the lower limit there, and then 1750, so roughly here, and then the upper is about 19. I mean, you definitely do just see this a little nicer like this. You get kind of the same concept. I'm just going to move this number over. Same thing. I mean, you see a lot. It looks like noise, a lot of randomness in the data. But once again, you don't see that. If you look over here, this is the the moving average data here, and I plotted it. Just this comes from right here. I got the average, so you can see the average as my central line, and then I did the upper limit. So using this analysis once again, it doesn't go beyond this upper limit. I do see that we do have a 0 point right here, which is kind of interesting. So to be quite honest, I am not sure if that's a signal or not because it's right on the 0 mark. I assume that there might be because, you know, we have a change right here. I mean, it's the exact same value. I guess maybe if we see a steady line like this, that would be something we can worry about. But at the moment, we see, you know, this moving range kind of moving back and forth. I guess I can go beyond and maybe calculate some standard deviations to see how much this is, you know, deviating from our average right here. But based on what I know so far, I would say that this is a pretty stable, you know, system and doesn't have very much deviation or randomization or signals. That concludes my video.